Hello Seahawks. Today you're going to be taking notes on linear expressions, and this is actually going to cover sections 1 and 2 of chapter 3. Here's your notes paper, and if you notice we're going to be simplifying linear expressions, we're going to be adding and subtracting linear expressions, and we're going to factor linear expressions. So let's take a look at our vocab. The first term we have is linear expression, and a linear expression is an algebraic expression in which the exponent of the variable is 1. Okay, if you look at your example there, we have some examples of a linear expression. Okay, negative 4x, 3x plus 5, 5 minus 1/6 x. Those are all examples of linear expressions. The exponent of the variable, okay, so if you look here, and I'm just going to bring that out a little bit, okay, here your exponent is 1, okay, on there. Your exponent is 1. Now, obviously there's not a 1 there, it's a given that it's 1, okay, but your exponent on those variables is all a 1. Just wanted to show you that, okay, and these are all considered linear expressions. Okay, the next term you have is like terms. And like terms are terms that have the same variable raised to the same exponent. Constant terms are also like terms. Okay, so I have 2x and 3x because it's just the 2x and the 3x, those would be considered like terms. 12 and 8 are like terms. Negative 8x squared and 5x squared are like terms because they have the x squared and the x squared, so they are considered like terms. Simplest form is an algebraic expression is in its simplest form when it has no like terms and no parentheses. Okay, so notice 12x minus 5. Those are not like terms because you have the 12x and then the minus 5. Okay, and this term here, and you're going to hear me talk about this, and I'm a little upset that I didn't add this on here, that's called your constant. And if you notice in the last vocabulary word, constant terms are considered like terms. Okay, that's called your constant in that. Okay, and then the other example we have is 3x squared minus 5x plus 4. There are no like terms there. That algebraic expression is simplified. You can't do anything else with that because we don't know what x is. So that would be a simplified algebraic expression. Okay. Just want to go back here to this. Okay, this algebraic expression has two terms. Okay, 12x is a term and negative 5 or minus 5 is a term. This algebraic expression has three terms. 3x squared is a term, negative 5x is a term, and 4 is a term. Okay. Algebraic expressions could, if it's simplified, could have many terms as if it's simplified. This is considered a binomial and a trinomial. Bi is 2, tri is 3. Okay, anything more than 3 is called a polynomial. Poly is your word part meaning more, many, right? So polynomial. I'll give you an example of one of those right down here below. If I had 5x to the 5th plus 3x to the 4th minus 7x to the 3rd plus 2x squared minus 9x plus 4. Okay, that algebraic expression is simplified. There are no like terms because I have an x to the 5th, x to the 3rd, x to the 4th, x to the 3rd, x to the 2nd, x, and then over here my constant is 4. That's a simplified algebraic expression. That's considered a polynomial because it has many terms. 1, 2, 3, 4, 5, 6, many terms. But the 2-term and the 3-term have the special name of binomial and trinomial. Oh, there's one more I didn't talk about. A monomial is one term. Here's an example of a monomial. Negative 4x. Okay, that would be a monomial. Hey, I'm just giving you some extra vocabulary that we will be talking about and using in class often. Okay, and the last vocabulary word that you have there is factoring expressions, and it's writing the expression as a product of factors. So you're going to be learning how to do this, but if you're given 24x minus 18, what you're going to do is you're going to factor out your greatest common factor, which in this expression is 6, and you'll have 6 times 4x minus 3. And we're going to talk about how to do that, but just so you understand what one of the words you're going to learn about is factoring expressions. Okay, let's give some of this a try. The first thing we're going to talk about is simplifying by distributing. So if you look at your first example, you have 2, and that parenthesis could mean times, right? 2 times 4x minus 7. So when you see a problem like this and you're asked to simplify, you can simplify this by distributing. It's actually the only way you could simplify it. So you're going to multiply the 2 times each term in the parenthesis. Remember before I was talking to you about the terms? Here's your first term and your second term, okay? You're going to multiply that 2 by each term. And I'm going to write this all out for you right now. And as you go on, you may not have to write everything out. But we're going to do 2 times 4x. And then we're going to do 2 times negative 7. And we're going to write it as a simplified expression. Okay? You're not going to have a final answer because we don't know what x is. We're going to have a simplified expression. So 2 times 4x, all you're going to do is 2 times 4, which is 8x. And then 2 times negative 7, is your answer positive or negative? You're going to put it's a negative because you have one negative. And then 2 times 7 is 14. That's your simplified expression. Can't do anything else with that. I can't combine those terms because they're not like terms. Okay, we have 8x minus 14 simplified. Okay, and again, this last number here is called your constant. So your answer here is 8x minus 14. And this is the proper way to write this. It should always be this way where the constant is last. Okay? Number 2, I have 1/2 times negative 4x minus 6. So you're going to take your 1/2 and you're going to multiply it by each term. Okay? I kind of think of this as, okay, you're walking into somebody's house. When you walk into somebody's house, you should say hello to everybody in the house, not just the first person you see. It is proper to say hello to everybody in the house, okay? Same thing here. The 1/2 is going to say hello to the negative 4x, and it's going to say hello to the negative 6. So we're going to take the 1/2, and we're going to multiply it by each term. 1/2 times, and I'm going to put this over 1, negative 4 over 1, and there's the x there. And then 1/2 times negative 6 over 1. Okay, now we're multiplying, and we have fractions here. Now we just learned how to do this, so hopefully we remember all that. Okay, we could cross cancel. 2 and 4, both are divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Okay, and then I'm going to multiply that. I have 1 negative, so my answer is going to be negative. 1 times 2 is 2. 1 times 1 is 1. I could put it over 1, but I don't have to. And then I have my x. Don't forget about your x. Okay, and you don't need to put it over the 1 if you don't have to. Okay, on the next one, when I multiply the 1/2 times the negative 6, I could cross cancel again with the 2. And this 6, they're both divisible by 2 again. 2 divided by 2 is 1. 6 divided by 2 is 3. Okay, I have 1 negative, so my answer is positive. I'm sorry, my answer is negative. And then I have 1 times 3, which is 3, and 1 times 1 is 1. I could put the 3 over 1, but I don't have to. Okay, if you did put them both over 1, that's okay, but to simplify it, I would leave it at negative 2x minus 3, and that's simplified. Okay, and then example number 3, we have negative, I didn't number that for you, sorry. Negative 1/4 times negative 8x, and negative 1/4 times negative 6. Don't forget, you have to say hello to everybody in the house. It's a proper way to do that. So we're going to multiply negative 1/4 times negative 8x, and I'm going to put that over 1. I'm going to run out of room here. Hold on one sec. Okay, I just needed a little more room on my screen here. So again, you're going to multiply negative 1/4 times negative 8x and negative 1/4 times negative 6. Proper to say hello to everybody in the house. You're going to multiply by everybody in the parentheses. Okay, and then you're going to do, that is a negative. It's kind of hard to see on your paper. Okay, so let's see, what can we cross cancel here? We could cross cancel our 4 and our 8, both divisible by 4. 4 divided by 4 is 4, and 8 divided by 4 is 2. I have, what I'm multiplying here, I have 2 negatives, so my answer is positive. 1 times 2 is 2, and x. And then over here, I have 4 and 6. I could cross cancel that. Oops, I have both 2. They're both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Okay, and I have 2 negatives, so my answer is positive. And I have a 1 times 3 is 3, and a 2 times 1 is 2. And that's an improper fraction, but you could leave it just like that, 3/2. And that's simplified. Okay, now notice when we did the negative times a negative, it was a positive. You have to put that plus sign in there. You can't just write 2x 3/2, okay? That doesn't make any sense. Because when you're multiplying here, you get a positive, it is also a plus sign, okay? You can't just write it like that. That's not correct. Okay, if you have any questions, just write them down real quick. Okay, and this next part, we're going to be simplifying linear expressions by adding and subtracting. Okay, and these first 3 are pretty simple. Okay, basically what you would be doing, they have these parentheses around them, but basically you would be kind of multiplying by a positive 1 on both of them. Okay, so 1 times x would be 1x or x. 1 times negative 4 would be a negative 4. Here you're again multiplying by a 1 times 2x, which is a positive 2x. And 1 times 8 is a positive 8. So basically, all I did was I just dropped the parentheses. And that's only because of the plus sign. Let me just get rid of this because you can't really see what I'm about to talk about. The plus sign here, because it's positive, nothing really changes. Now from here, we're going to combine our like terms, okay? Remember earlier in your vocab I talked about like terms, terms that look alike. So looking at this expression, this is not totally simplified yet. In order to simplify it, you have to combine your like terms. Well, the first set of like terms I have here, and I'm always going to start with my variables. I have x and a 2x, okay? And this x is positive and this 2x is positive, so they're same signs. Same signs you're going to add, and there's an invisible 1 in front of here, right? So 1x plus 2x, okay? It's all you're going to do is add your coefficient, okay? This is your coefficient. So 1 plus 2 is 3. And then you just bring your x over. It's like 1 apple plus 2 apples is 3 apples. It's not 3 apples. Okay, so 1x plus 2x is 3x. And then we're going to combine our other like terms, which we have negative 4 and a positive 8. Okay, those are our other like terms. Now, do I have same signs or different? Those are different signs. I have a negative and a positive. So different signs subtract. 8 minus 4 is 4, and that would be a positive 4 because 8 is my larger number. So this answer, simplifying, is 3x plus 4. That's it. Okay. The next one we have negative 3x plus 5, and really on this one again you have a positive here and a positive here and nothing here, so you're just going to actually bring this down without the parentheses. You don't even have to. You could work right within the parentheses, but you're going to see on the next one, not this number 3 here, but the next examples after these 3, you are going to have to do something, so I don't want you to get into that habit just in case. Okay, now I'm going to combine my like terms, and my like terms would be negative 3x, I'm just going to draw a line here, and a positive 12x. Okay, you have different signs subtract. 12 minus 3 is 9x. And then I'm going to combine my positive 5, and a negative 7. Again, you have different signs subtract. 7 minus 5 is 2, and it's a negative 2 because 7's your larger number. So my final answer is 9x minus 2. Okay, and this is the proper order. You have your variable and then your constant at the end. This is your constant again, remember. Okay, and the last one is a little more difficult because we threw a decimal in there. And there's just the positive here, so it's a negative 3.2x, and I'm going to run out of room again, so let me get this on the next page. Hold on one sec. Okay, so we have the negative 3.2x plus 4, and then we have the positive 1 that you're distributing here, which gives us a positive 5x minus 7, just bringing everything down there. Okay, now we're going to combine our like terms. Our first like term is our negative 3.2x and our positive 5x, okay? We have different signs, so you're subtracting, okay? And I'm just going to do this on the side. You're subtracting 5, minus 3.2, okay? And you just learned how to do this, although you learned it last year. 10 minus 2 is 8, 4 minus 3 is 1. Bring down my decimal, I get a 1.8x. Okay, and then my other like terms, we have positive 4 and a negative 7. Those are different signs, subtract. 7 minus 4 is 3, and it would be a negative 3 because 7's the larger number. So my answer there is 1.8x minus 3. Okay, examples 4, 5, and 6 get a little bit more complicated because we have terms in front of our parentheses. So first, you're going to need to distribute. Okay, like on the last ones, there was nothing to distribute. If you look on number 4, you have something that you need to distribute. You have your negative 2 here that needs to be distributed, and then you have a negative 2 here that needs to be distributed. So you're going to do negative 2 times 3x. And that would be a negative 6x. Okay, and I'm going to change my color on each one here. Then you're going to do negative 2 times negative 5, which would give you a positive 10. Okay, and then you're going to do negative 2 times negative 2x. It's not really a good color, I don't think. Which is a positive 4x. And then you're going to do negative 2 times a positive 4, which gives you a negative 8. Okay, now you're going to combine your like terms. Okay, so I have negative 6x, and I always start with my x's first. And a positive 4x, that's different signs subtract. 6 minus 4 is 2. It's a negative 2 because 6 is the larger number, x. And then you have a positive 10 and a negative 8, which again is different signs subtract. 10 minus 8 is 2, and 10's the bigger number, so that's a positive 2. And that's your final answer, negative 2x plus 10. Okay, the next one is a little tricky, so I don't know if you should pause it and do this one on your own. Okay, let's go on to that next one. Okay, we have positive 2 times a negative 4x, which is a negative 8x. And then we have a positive 2 times a negative 12, which is a negative 24. And then we have a negative, and there's an invisible 1 here that we're going to distribute. A negative 1 times 3x, which is a negative 3x. And then that same negative 1 needs to be distributed to the other guy. You got to say hello to everybody in the house. Negative 1 times negative 2, which is a positive 2. Okay, now I could combine my like terms. I have negative 8x and a negative 3x. That would be same signs, add. 8 plus 3 is 11x, and it's a negative, because 8's the bigger number, negative 11x. And then a negative 24 plus 2, I have different signs, subtract. 24 minus 2 is 22, and that would be a negative 22 because 24 is the larger number. And that's simplified. Okay, let's try number 6. Okay, I have a 3/4 times 3x. Now this one's difficult because you have the fractions now. I'm going to put that 3 over 1, the 3x over 1. Okay, well that's a positive answer, and then 3 times 3 is 9, 4 times 1 is 4, so that's 9/4 x. And then we're going to do 3/4 times negative 2, 3/4 times negative 2 over 1. Okay, here I could cross cancel my 2 and my 4, and I have one negative, so my answer is going to be a negative. 3 times 1 is 3, and 2 times 1 is 2. We're going to leave that as an improper fraction. And then we're going to do my negative 1/4 here times 2x. So negative 1/4 times 2 over 1x. Okay, I could cross cancel here. And that would be a negative because I have one negative. 1 times 1 is 1, 2 times 1 is 2, and that would be an x. And we're going to do negative 1/4 times negative 20. Negative 1/4 times negative 20. And again, I could cross cancel my 4 and my 20. Okay, and I have a negative times a negative, that's 2 negatives, so my answer is positive. And it would be a 5 over 1, or just 5 is fine. Okay, now this is tricky because we have these fractions here, and we got to combine like terms. Okay, so we're going to combine here. We have 9/4 x and negative 1/2 x. Okay, now if you want to do this on the side, you can. 9/4 plus 1/2. Okay, and you don't have to write it all out, but some of it you should. I need to get my common denominator, which is going to be 4, and that would be 2/4. Now I can add that, and I get 11/4. And remember when I told you guys to just leave your improper fraction as improper fractions? It's totally fine in these problems. So I have 11/4 x, okay, and then I'm going to combine negative 3/2 and a positive 5. So if you want to do that also on the side, I'm just going to box this out here. And we have a negative 3/2, and I'm going to add that with my 5 over 1, okay, which would be a common denominator of 2 times 5 is 10. 10/2 is 5, okay. Now I have different signs, so I'm going to subtract. 10 minus 3 is 7, and it's a positive 7 over 2. Okay, so my final answer here is 11/4 x plus 7/2. That's simplified. Okay, for this video, I'm going to stop right here. The other part I'm going to show you in class. So if you could just hold on to the notes, and I will continue later. Ryan does have a show for you, so I'm going to let him go. Have a good night.
Hi. I'm going to pause it. Welcome to the Ryan Show. Right here we have a roller coaster that I made up. I call it the machine because it's a machine. See? So yeah, and then this right here that I just added is the air catcher, and it catches air so that the air doesn't blow into people's faces when they're looking out the windows. These are the windows. And this, no, and this is our fire. Okay, so it goes zooming speed. It goes. Goes like faster than that. Goes like this. Or this. And you don't even know where their circles are coming from because it's so fast. So yeah. Okay. So today you will be learning fractions. Okay. So let's do 32 divided by 4. Now, I mean division. I meant the wrong thing. So, first, what you would do is pretty much 4 times what equals 32, and 4 times 8 equals 32. So, you would put the 8 up there, and then you would do 30, and then you would put the 32 down here, because 8 times 4 equals 32. Then you would subtract that, and subtract 32 minus 32 would equal 0, 0. That means there would be 0 remainders, and your answer would be 8. Okay, now let's do another one. Nope. Let's do 4 divided by 60. 6. Since 4 times what equals 60, you would think. 4 times 15 equals 4 times 15 equals 16. So yeah. 4 times 15 equals 60. 60. Okay. So then you would do 4 times 15 equals 60. So you would put 60 down here. You would subtract that. 0, 0. Remainder 0. And 15. Okay, next. Now let's do a different one. Here's my last problem. 5 divided by 5 divided by 105.
No, that's 105 divided by 5.
Yes, 105 divided by 5. Okay, 5 times what equals 105? But nothing can equal 105. 5 times what equals...
Oh, you wanted one that didn't equal? Oh, then that works.
That doesn't work.
So change it to 107.
I meant not the 7, the 7. I mean not the 5, not the 7. Okay, so since 107 doesn't equal 5, since nothing 5 times whatever equals 107, we would choose what is closer to 107. Like 5 times 8 is 40. But we would even get... Okay, so... let's start out with... Let's go up to 5 times 12. 1... Well, so, wait, yeah, 1, 2, 5. So we would multiply that. 5 times 2 equals, everybody, 10. 5 times 1 equals, everybody, 5. 60. No. Let's do 5 times 13. And let's change it to 5 times 50. 5, 1, 5, multiply. 5 times 5 equals, everybody, 25. And then 5 times 1 equals 5. How'd you know that I was going to say everybody? Plus 2 equals 7. 75. Oh no, still not close. Let's go up to 17. Okay, 5 times 7 is 35. 5 times 1 equals 5. Add 3, 5, 6, 7, 8. 85. Come on, not close enough. Come on, guys, you can do it with Mr. Smiley.
Oh, 107. Alright, knock this out, Rye.
Come on, you can do it. How about we do? Let's do 21 times 5. 5 times 1 equals 5. 5 times 2 equals 10. 105. Then if we went up to 122, 5 times 2 equals 10. 1, 0. And then I've done another 2 equals 10, 11, 1, 1. Oh no. So, what is closer to 107? 105 or 110? 7, 8, 9, 10. There's a 3 difference. Then 105, 106, 107, 108, 109. About a 4 difference. So 22 would be our answer. Okay, so 20. I mean, 20.
About. It would be about.
2 would be about our answer.
21.
Since 5 times 100, since 5 times 22 equals 110, we put 110. Come on, Mr. Smiley. Okay.
Wrap it up.
Since 5 times 22 equals 110, we put the 110 down here. We subtract that. 0 minus 7, you can't do it. You can't do 0 minus, you can't borrow from the 0, so you borrow from the 1. 1 turns into a 0. This turns into a 10. Then we cross that off and turn it into a 9. This turns into a 17. 17 minus 0 equals?
You can't. It's too high. You have to do 21.
Oh. 21, we're going to change that to. La, 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 la. See my magic pen eraser. 21. Okay, so 5 times 21 equals 105. So 5 minus 7 equals 2, 0, 0. So 21 remainder 2.
But we don't have remainders anymore in 7th grade.
But you don't have remainders. So thank you for watching the Ryan Show. Thank you for watching.